Hello and welcome to OJ Safety. On this channel, we discuss practical vessel safety topics, lifeboats, Davits, LSA, FFE, load testing, inspection planning, certificates, and the compliance details that decide whether a port call stays routine or becomes expensive. Today, we are looking at Davit load testing, how it is planned, performed, and documented. Davit load testing is not a formality. It is the moment where the launching appliance has to prove it can safely carry the required load. The brakes must hold, the winch must operate correctly, the structure must show no unsafe deformation, the controls must respond properly, and the documentation must be clear enough for class, flag, and port state control review. If the test is done badly, the vessel does not just get a failed certificate, it gets delay, re-inspection, extra attendance, and another urgent problem before departure. Davit load testing is linked to SOLAS Chapter III, Regulation 20 IMO Resolution MSC.402 96, and relevant operational guidance such as MSC1 Circular 1206 Revision 1. In practice, the 5-year inspection normally includes proof load testing of the launching appliance. In many cases, the test load is 1.1 times the safe working load. That means 110% of SWL. But the exact test method, acceptance criteria, and witnessing requirements must always be checked against the maker instructions, class requirements, and flag requirements. That is the first rule. Do not load the equipment until the procedure is clear. Phase 1. Preparation. A good load test starts before anyone touches the Davit. The first phase is preparation. The service team reviews the original maker manual, previous inspection reports, wire rope certificates, brake service history, hydraulic records, and any previous findings. The safe working load is confirmed. The target proof load is calculated. The test sequence is agreed. The risk assessment is prepared. The work area is planned. Communication lines are defined. Stop criteria are agreed before the test begins. This matters because most serious problems are easier to prevent at the planning stage than during a suspended load test. Nobody wants to discover missing certificates, wrong test equipment, or unclear class requirements when the water bag is already hanging. That is not engineering. That is gambling with paperwork. Phase 2. Pre-test inspection. Before the load is applied, the Davit must be inspected. Technicians check arms, pillars, foundations, brackets, weld areas, and structural supports for corrosion, cracks, distortion, or visible damage. Running gear is inspected too. Sheaves, bearings, wire ropes, sockets, thimbles, reeving, hooks, falls, and alignment. Hydraulic systems are checked for leaks, pressure condition, and proper operation. Electrical controls, limit switches, interlocks, and emergency stop functions are verified. Brake condition is especially important. The brake must be adjusted correctly, hold properly, and operate safely before the proof load is applied. If something is wrong, it is corrected first. You do not load a compromised system just to see what happens. The ocean already provides enough bad ideas for free. Phase 3. Test equipment. For the proof load test, certified water bags or approved test weights are used. Water bags are common because they allow smooth and controlled loading. The load can be increased gradually without shock loading the structure. Calibrated load cells, flow meters, and gauges are used where required to monitor the applied load. The certificates and serial numbers of the test equipment are recorded in the job file. That includes water bags, load cells, gauges, and any other critical measuring equipment. This is not just admin. This is the evidence that proves the test was controlled, measured, and traceable. Without calibration records, even a successful test can become a documentation problem. Phase 4. Dynamic proof load test. The dynamic proof load test is the actual exam. The load is applied gradually to the required level, often 110% of SWL, where applicable. During the test, the team monitors the Davit structure, hydraulic pressure, wire rope behavior, alignment, brake response, winch performance, and any unusual noise or vibration. The system is hoisted and held to confirm structural behavior and brake holding capacity. Then it is lowered under control to confirm smooth operation, synchronization, and safe brake performance. If readings drift, behavior changes, or any visible deformation appears, the test is stopped, the load is reduced, the issue is investigated. Where needed, further inspection or non-destructive testing may be required before the test continues. A good test is not about forcing the equipment to pass, it is about proving safely and clearly whether the system is fit for service. Phase 5. Post-test inspection. After the load is removed, the inspection is not finished. The team checks the Davit again. Weld areas, foundations, brackets, sheaves, brake components, hydraulic fittings, and load-bearing parts are re-inspected for cracks, distortion, leakage, or movement. Brake settings and control functions are verified again after the load. The team records achieved load, test method, equipment serial numbers, calibration data, photographs, inspection findings, and any corrective actions. This post-test evidence is what turns the test into a usable record for the vessel. Class, flag, and PSC inspectors do not only want to hear that the test was successful, they need documentation that shows how it was done. Documentation, efficiency, and CTA. After completion, OJ Safety prepares a load test report with the test parameters, achieved loads, photo evidence, calibration references, technician details, and inspection findings. Where required, the report is prepared for owner, class, or flag endorsement. Once accepted, the documentation becomes part of the vessel's LSA file and supports the 5-year inspection record. The efficient approach is to plan Davit load testing together with related work, lifeboat inspection, release gear checks, annual LSA inspection, FFE inspection, CO2 systems, SCBA, EEBD, fire extinguishers, and emergency fire pump testing. 1 port call, 1 coordinated attendance, 1 clean documentation package. OJ Safety is an ISO 9001 certified and RINA-approved marine safety service provider based in Klaipėda, Lithuania. We support Davit load testing, lifeboat and rescue boat inspection, LSA and FFE services across the Baltic region, Poland, Scandinavia, the North Sea area, and wider Europe. For the full written breakdown, inspection planning, and quotation request, visit ojsafety.com or contact us directly at sales@ojsafety.com.